Hello students! Today we're going to look at adding and subtracting rational expressions. Since rational expressions are just more complicated versions of fractions, we're going to go back to adding and subtracting fractions for some inspiration. Let's look at a basic example. 1/2 plus 1/6. When we're adding two fractions, remember we need a common denominator. In this case, that common denominator is going to be 6. Whenever we change a denominator, we also have to change the numerator. To get from 2 to 6, we have to multiply 2 times 3. So we also multiply the numerator by 3. 1 times 3 gives us 3. So 1/2 can be rewritten as 3/6. The other fraction, 1/6, is going to stay the same because it already had the common denominator. Once we have a common denominator, we keep the common denominator and we add the numerators across. 3 plus 1 gives us 4. So we end up with 4/6. And there's one last step. Whenever we can reduce a fraction, we always should. 4/6 reduces to 2/3. And that's our final answer. So when we're adding fractions, first we need a common denominator. Then we need to figure out the new numerators. Once we've done that, we add the numerators across and we reduce the fraction. We're going to do a similar process when we are adding and subtracting rational expressions, but we're going to look at this in two different chunks. First, we're going to look at problems where we already have a common denominator. Those are a lot simpler. And then in the next video, we're going to look at problems where we don't have a common denominator. So let's start with problems where we already have a common denominator. And we're going to start with 2x minus 1 over 3 plus x plus 4 over 3. Now we know when we already have a common denominator, we keep that denominator and we add the numerators. And we're going to do the same thing here. We're going to keep the common denominator of 3, and then we're going to add the numerators. And we're going to do that by combining like terms. 2x plus x gives us 3x, and negative 1 plus 4 gives us 3. So when we add those numerators together, we get 3x plus 3. Now we want to see if we can reduce, and remember, when we simplify rational expressions, we need to factor any polynomials that can be factored. So in the numerator, we can pull out a GCF of 3, and then that leaves us with x plus 1. And in the denominator, we have 3 as well. And we can see that there's a factor of 3 that can be canceled in the top and bottom. When we cancel that, we're just left with x plus 1. So when we add 2x minus 1 over 3 plus x plus 4 over 3, we end up with a final answer of x plus 1. Let's do another one. This time, we're going to look at x squared over x squared minus 25 plus 25 minus 10x, also over x squared minus 25. Because we have a common denominator, we're going to keep that common denominator, and then we're going to add the numerators together. Now, because there's no like terms in the numerators, we're just going to transfer the numerators over, and I like to put things in standard form, so I'm going to put the x squared first, and then the negative 10x, and then the positive 25. That's going to be helpful for us in the next step, because at this point we want to see if we can simplify the expression, and to simplify we need to factor, and things are usually easier to factor when they're in standard form. X squared minus 10x plus 25 can be unfoiled. we need two numbers that have a product of 25 and a sum of -10. Those numbers are -5 and -5. So we get x minus 5 times x minus 5. Now in the denominator, this is a difference of squares, so we can factor it as x plus 5 times x minus 5. Now we do have a common factor in the top and bottom. We can cancel out an x minus 5, and when we do that, we're left with x minus 5 over x plus 5, which is our final answer. We're going to do one more problem with common denominators, but this time we're going to look at a subtraction. Let's look at 5x plus 1 over x squared minus 9 minus 4x minus 2 over x squared minus 9. When we're subtracting fractions with the same denominator, the only difference is we're going to be subtracting the numerators. However, we have to be very careful. When we take one polynomial and subtract another polynomial, remember that that subtraction must be distributed to each of the terms in the other polynomial. So what we're going to do here is we're going to keep our common denominator, but we're actually going to rewrite the numerators. We're going to keep the first one the same, and then we're going to distribute that subtraction to the other terms. So this is going to be a minus 4x, but then when we subtract a negative, it's going to become plus 2. I write all of this out just to make sure that I don't make a mistake, because if we try to do it mentally, we're more likely to get something wrong. Now that we've combined all of these into one numerator, we can combine like terms. 5x minus 4x gives us just x, and 1 plus 2 is 3. So we have x plus 3 over x squared minus 9. If we want to see if this simplifies, we're going to have to factor that denominator. It's a difference of squares, so it becomes x plus 3 times x minus 3. And we do have a factor that we can cancel. There's an x plus 3 in the top and bottom. This leaves us with x minus 3 in the denominator. And we need to put something in the top, and that something is going to end up being 1, because that x plus 3 was technically the same as 1 times x plus 3. So we've got a 1 left in the numerator, and our final answer is 1 over x minus 3. Now, all of these problems, believe it or not, are on the simpler side because they already had a common denominator. In the next video, we're going to look at examples where we need to create a common denominator. We need to find the LCD. That's going to be a little bit more work.